All right, hello everyone. Now we'll cover streams. So you already know collections in Java, right? There's a collection is array, there's lists, there's sets. What do you mean the last slides? There are no slides that were just random scribbling I did on the. Yeah, there were just random scribbles I did. If you want to see it, you could go watch the last video. But it's just random stuff. It's not a slide, it's Microsoft Paint. So there's lists, there's sets, there's maps. These are all collections, and they're called collections because they are a collection of objects. So let's say you have a bunch of items in a collection, right? Let's take an example of a cashier at a shopping mall. So you have a basket full of objects, and the cashier is there. And in the middle, you have let's just say conveyor belt, and it's going like this. And each item they have to scan the item, right? So in good old Java, if you want to go through every object, you could do like a for loop for, object for inside the collection name. And for each collection, you can just do like scan, just O, and you could iterate through all of them using that. But what streams do is they take every single item in a collection. So let's say if there's an array with like 5 numbers. What a stream would do is it takes each of the items and it puts it in a very nice, neat list. So one, two, three, four, five, these are all the items. It puts them in a list and it's like a stream, like how a river flows. Like there's a river that's flowing down the mountain. You could think of a stream like that. And on the like in the middle, you can perform processes on it. So it's a river. Here, let me make it look like a river. So the river is flowing down the mountain like this, right? So in the middle, suppose there's a guy here and he puts some, let's say, yellow paint into the river. So here he puts yellow paint into the river. Now suddenly the rest of the river is going to become yellow. Like the paint will it will keep flowing. And from this point, he put in the paint and now it's yellow. And in the end, let's say there's another guy here and he puts in, let's say, red paint. And once they put in the red paint, the rest of the stream becomes red. And there's a person standing at the end here with a bucket, and they put whatever is at the end, they put that into the bucket. So at the end, they end up with red paint in the bucket. So that's basically how streams work. So stream will take every element in the collection. It will make it like a river. It starts flowing. So this is one, two, three, four, and five, and they're just flowing. Then what the people are doing here and here, these are called methods, intermediary methods. So you could apply these methods on the stream, and it just keeps going. So in a stream, there are two types of methods. Oh, I forgot I was supposed to give this example. Well, you understand it now anyway. So there are intermediary methods and there are terminal methods. So you saw how when this guy put in the yellow paint, you could think of it as a method, and in the input it takes a stream as the input, and it outputs a stream as well. So the water came in, it became yellow, and the water came out. So there's 1, 2, 3, 4, 5. If we have a method here that multiplies it by 2, it will take a stream as the input and it will still leave a stream as the output. Each of these items will go inside, something will happen to them, and they will keep going. So if it's multiplied by 2, then it becomes 2, 4, 6, 8, 10, and it just goes on. So that's what a method is. That's intermediary methods. And the other type is terminal. Terminal method takes a stream as the input and it returns something. It could be a set, it could be an element, it could be whatever. But the most important thing is it stops the stream right there. So a stream does not stop until a terminal method happens. So some examples of intermediary methods is like the most important ones are filter, map, I guess limit as well. And I don't know if reduce, he has done reduce yet or not, but yeah, these ones. Terminal, there's for each, there's collect, there's like two, and then something. So these ones. But let me start with an example to make it easier. Hmm, Actually, here, now you remember what I discussed about lambdas? I think like last meeting or last to last. Now lambdas actually come in handy. So as you remember, lambda is a function that takes something and it returns something. So you could give like it takes x and returns x multiplied by 2. It takes, uh, okay, so that's what a lambda is. So, streams, I don't know how I should start. Let's start with the dot stream method, dot stream. This is something you can call on collections. So if you have an array and you call the dot stream method on it, it will convert that array into a stream. So you have this array, right? 1, 2, 3. If you call dot stream on this array, or if you save it into a variable and call dot stream on that variable, this will change this into 1, 2, 3. It's a stream, and you can perform operations on the stream. Then you can perform an intermediary method on it. So let's start with the map actually. Let's start with map, then go filter, then go limit, then go reduce, reduce. So map, let me just erase everything. Map. Mapping, you can think of mapping as like mapping the values. So suppose you have a stream, right? In the stream, you have 1, 2, 3, 4. What map will do is it will take, since it's intermediary, it will take every element of the stream and do something to transform the stream. So let's say you have 1, 2, 3, 4, and you want all of them to be, you want all of them to have +1. So map can do that. So you have an array, 1, 2, 3, that's an ugly 3, 4, dot stream. This will turn it into a stream, dot map. And inside the map, you need to give a lambda. So map is a function that will run on every single element of the stream. So the input will be x. And what will happen to x? You give it a dash greater than. So what will happen to x is x plus 1. So, stream will have 1, 2, 3, 4. And after map is done, it will be 2, 3, 4, 5. Like this will be this new stream. And you can print them easily by doing for each and just S out. I'll show you how it looks like in a real implementation. So for each is a terminal method. It will just do this. It will do whatever you pass it in for every single element of the stream. So let us go there. Main. So I will create an array first. Okay, in this is equal, and let's say nums dot stream. This will create the stream. Oh, like why is it stream working? Okay, so when dealing with an array, you have to do arrays dot stream. I think that the professor will always use a list. For that reason, let me just create a list. I think all you will have to do is create the object to get the list. Like you will be provided with a list of the stuff. So you can just create an array list of integers. Wait, my original thing was correct. What's the problem? Oh, okay. It just returns the list. Yeah, we use get all, but what does get all return? That's what I'm trying to explain. Get all will return a list. So when you're dealing with a list, you can turn a list into a stream very simply, like by calling the stream method on it. So now stream will convert all of the list into like the numbers. So it's 1, 2, 3, 4, and then you can do stuff to it. By the way, I just pressed enter. You can even write it in one line. I prefer enter. So well, it makes it easier to, read. So what do you want to do to the stream? You want to add one to every number. So it will be mapped because you're transforming the stream. So you give it a lambda. Okay, what does map take? X. X is each element. And then what are you returning? X plus 1. That's it. Then for each, you want to just print it. So by the way, this is called the method as a reference operator. Whenever you're dealing with a method, right now you have this. But if you call a method using dot, it will run the method. But if you say this will show this method as an object, as a variable, and you can pass this method into other things. So basically, the string turns a list to a string, and the map modifies the string. No, it's not a string. It's a stream, it's a bunch of objects in a flow. It's like a conveyor belt, Like, have you ever been to a factory? In a factory, you will see that there is a belt going like this, and the belt is just moving. There's like objects on it. Let's say like an apple factory where there's like an apple, and here there is a cleaning machine. Each apple goes through the cleaning machine and it comes out as a washed apple, and it just keeps going. and there's another machine which is like, let's say, the polishing machine. Then each apple goes through the polishing machine and it gets polished. And at the end, all of the apples fall into a box, and you take this box to the supermarket. And at the start, you probably have like a truck of apples straight from the farm. So all they do is call dot stream on it so that each apple can be put in a neat row and can be processed easily. Does it make sense? Yeah, all right. And then for each, you just print it. So this should print like 2, 3, 4, 5. And you can see it does 2, 3, 4, 5. So this is a simple example of map. I'll show another one, which is string. So this one is a bit more advanced, but I think you guys can handle it. So list of strings, names, let's say three names. So map transforms the list. So right now I have the list of names, right? So the stream right now would be like the names. So so this is the stream. I want the stream to be changed, like I want it to be transformed. So that right now this is the stream. It goes into a mapping function. And on the other side, I want the stream to become only the first letters of each name. So I want this once map outputs, I want this to be S, F, and T. So the stream has been mapped. It has been transformed into something else. Before this, the transformation before was it was 1, 2, 3, 4. It went through a mapping function, and when it came out, it was I added 1 to everything. So it was like 2, 3, 4, 5. And you can run a map after a map again to do something even more. Any, intermediary functions, you can put as many intermediary functions after each other as you want. Only one terminal function is allowed. Intermediary, you can put as many as you want. So here we have three names in a list. And let's go names dot stream. Okay, and then we want to transform the stream, right? So we do map. And what do you want to do with each name? Okay, X, you can call X anything, by the way. You can do name. It's a variable name. And then what do you want to do to it? All you want to do is return the character at the first index, well, 0th index. So that would be name dot car at 0. So now it becomes the stream of S, T, and F. And for now, let's just for each and print everything. So you can see it should print SFT. Yep, STF, because Tanishq is second. So that is mapping. If anybody has any questions about mapping, just send a message right now. If no, I'll assume it's all clear. So that is it for map. Now I'll show filter. So a good example of filter would be, I'm sure everybody has seen like those videos where there's muddy brown water. It's not fit to drink. But why is it muddy? It's because the bad water, like let's say this is water. It has like dirt particles in it. Hmm. Regardless, like filter is basically where in SQL. Yeah, it is. But this filter is way more advanced. Like, yeah, you can do anything in this filter. So it's like the SQL one, but SQL is basically like where this is equal to this. But the Java filter, you can put a lot more. You can do like even whole API calls through the filter. But yeah, basically you have water with the dust in it, right? Or more accurately, it would be, when you come to Hungary, everybody goes through a filter where there's a guy and it's like it's the border and everybody has their passport. He does a very simple filter. This can either be true or it can be false. No other value. It's Boolean. If you have the visa, okay, then you pass through. So you can just see it as like a stream of, it's like a stream. You guys are a stream and you're passing through a filter. Only the people for whom this returns true, like has visa, yes, okay, you go. If you don't have a visa, you don't go anywhere. Like in Java, at least you will be thrown into the garbage collector. I hope that doesn't happen in real life. In real life, they will send you back to your country. But in Java, only the people who have the visa will pass. So how does the dot filter method work? It takes a lambda function. It's also called a predicate. If you look at the notes posted by Dr. Toth Robert, it will say predicate. A predicate is basically a lambda function that returns a Boolean. So it's true or false. That's it. It filter will take a true or false value. So what filter will do is it will go through every element of the stream and it will run this function on them. So how can we, a good example of filter would be again with numbers. We have a stream, right, of 1, 2, 3, 4, and you only want to keep the numbers that are greater than 2. So you have the stream, you do filter where x lambda and x is greater than 2. So by the way, this basically means this is basically this. It's a function that takes like, let's say, Boolean. Let's just give it whatever name. It takes int x. Yeah, it's like a condition. Int x, and you will do return x greater than 2. Basically, this section is a return statement. And so, this will either return true or false. So, which makes it a predicate. If it returns true, then x will be allowed to pass in. So, 1, 2, 3, 4 goes into the filter, and what comes out is 3, 4. 1, 2 is it's gone. I don't understand the Boolean line. Basically, like a condition, you cannot return like 3, 4, 5, like a number. Does it make sense? It can only return a Boolean for filter. If it's a true value, then it will, pass on. If it's not a true value, then that value will not be, it will not make it pass the filter. What do you mean the Boolean is big? This is a function that I made for an example. Like is big is a function that checks if it takes an integer x and it returns, like it checks if x is greater than 2. So this whole function, you can write it in one line by just writing this. This is the power of lambdas. Does it make sense? I'll just implement that example in real life. I'll create a list of numbers, and it will be 1, 2, 3, 4. So the first thing you do is just turn it into a stream, okay, and then you filter out. So now see, it says predicate. So this should return true or false value. So you take x lambda. So this function will return whether x is greater than 2 or not. So let me just, I think if you don't have experience with Java, you will be confused with it. Java or any language. But see, if you pass in a condition like x is greater than 2, well, I can't write x here, but like 3 is greater than 2, it's a condition, right? This automatically gets replaced with true. So it will print out 2. No, it will print out true. So let's say you have two values. Int A is 54 and B is 2. No, well, 2. And you check, okay, print out A is greater than B. This will be a Boolean. See, it will say true because A is greater than B. If you say, okay, is A smaller than B? False. So what we're doing here, like as you remember, the second part of the lambda is basically a return statement. So this returns x is greater than 2. If that value in the stream is greater than 2, it will keep going in the stream. If it is not greater than 2, it will die. So now you can just print everything that is in the stream and see what happens. See, 3, 4. So that is filter. And let's see, there's limit. Limit basically, there is dot limit. It will just keep it will just keep the ones that are going in. Like, it will just keep the first few. So if you say limit 5, it will only keep the first 5 parts of the stream. There is dot sorted. So I'm hoping you guys already know what comparators are and how comparators work because it was the whole point of HLPL2. So I won't cover comparators in detail, but there is dot sorted. So you could go like dot sorted. Dot sorted will use the default comparator for the numbers. So I guess my array is already sorted, but what if I want like 1, 2, 4, 1, 2, 4, 3. You can see it says 3, 4. It filters out. It takes only the numbers that are greater than 2. Then it sorts them in natural order, and then it prints them out. You can also do like comparator dot reverse order. This will, I think it will just keep it how it is because 4, 3. Yep, 4, 3. So sorted takes a comparator as the parameter. And you can see what it takes, by the way. You don't have to remember all this. I remember all this because I practiced. So if you hover over it, see, sorted, and it says that it takes a stream and it sorts them, sorted according to the natural order. So you also will have access to this file by Professor Thoth. And in the head, you can just see sorted usages. This is without a comparator. It is sorted with a comparator, that way. So this is sorted. Give it a read if you want to understand. So the meeting is about to end. In the next one, I'll continue streams, but with terminal operations. So see you guys in the next one.